Hey guys, it's Ben, and today I'm going to be doing a walkthrough of the Mustacchio TryHackMe challenge. This is a boot to root type of box. I thought this was quite fun. It's a fairly simple one, but let's get into it. So we're given an IP address like normal. I always begin my my CTFs by creating a directory, so I'm going to create a Mustacchio directory. There you go. CD Mustacchio. And I am going to get a terminal set up. We'll zoom in each of these a little bit so you can have a nice view. I'm going to make directories recon, exploits, and recon mmap. I'm going to cd to recon mmap. And this is where I'm going to do my mmap scan. Paste the IP in there. I'm going to start off, let's just do top ports 2000 T4, and we'll output this to fast tcp.log. So this top port's 20,000. This is the most common 20,000 ports I'm going to scan. I'm not doing a full port scan yet because it may take a little bit of time. I'm just doing this quick one to give us some stuff to work with. After I discover what ports are open in these top ports, I will do a thorough one covering all the ports just in case we miss anything. So I can see there are 3 reported ports being open, and it's supposedly SSH HTTP and this UltraSeek HTTP on port 8765. So one thing to note, I haven't done any service enumeration, so it's only taking a guess of what the service is here. Basically, without the TAC SV flag, it just chooses the service on what the most common port is. So there is a good chance that yes, this will actually be SSH and this will be HTTP, but without doing a service scan, we won't know for sure. So now we've got this information. What I will do is I'll change this to thorough tcp.log, and instead of top ports, I'm going to strictly specify 2280.8765, and also do TAC SV for service enumeration. I'll do TAC SC for default scripts, and that's all I'll do. We can go to this port here because we can also check it's a HTTP by actually seeing if there's a website hosted on it, and there is. So we've got this Mustacchio website, the beacon to all mankind. Our website templates are created with inspiration, checked for quality and originality, and meticulously sliced and coded. So we can look at the web technologies here, and we can see it's an Apache web server. It gives us the version here, 2.4.18, and it also says it's running on the Ubuntu OS. So if we go back to our thorough scan, this will probably also verify that this is Apache. It gives us the version there, and it also does say it's on Ubuntu. This also verifies SSH and the actual application that the server is OpenSSH. So we've got some more information on that. And this other port 8765 has verified it is actually a HTTP service as well, and it's running Nginx. That's the web server. So it says robots.txt. There is one disallowed entry, and it looks like it's just this /. So I will quickly verify this. Sometimes developers like to hide stuff from web crawlers and search engines. So we can see, look, this is just /. There is nothing interesting in the robots.txt. Let's do some more manual looking around. We can hover over each of these tabs and look in the bottom left hand corner, and we can see this one goes to a gallery.html, this one goes to an about.html, this one goes to a blog, and this one goes to contact. Sometimes you see there's a hashtag there, so that's when we'll know the button doesn't do anything, but we can see this does take us to an about, and we've got some lorem ipsum, so there's nothing interesting here really. We could obviously look at the source code, see if there's a comment anywhere, and we've got this gallery, and we can hover over each of these, and it will just take us back to this web page. This does nothing. done the about, I think. Let's look at the blog. Also, more lorem ipsum hovering over these also takes us back to the blog.html. The contact, it looks like we've got some a contact form. If we send this, we can see it looks like it sends a GET request, and the parameters up here are sent as part of the GET request. So there's not a lot here, right? We could obviously do some directory enumeration, or we could have a look in the source code, and we can sort of reveal some directories which weren't available to us because it's sort of loading in files and scripts and CSS files. So we can see that there's this custom directory, and then in there's the CSS and mobile. A lot of times going to the this directory like custom, it won't be available. Let's see if we can access this, and we can. We do get this index of /custom, so we can see there are JS, CSS, and there's JS. So this is typically where a lot of like the web templates are stored. So there's like a mobile.js. If we look at this, this is just some sort of accessibility template for, I guess, people who are viewing this on a mobile. And if you look at the CSS, same sort of thing, mobile and style. One thing which did stand out to me in this JS was this users.back. This is not something you would usually see. So let's download this, right? We've got users.back there. What I am going to do, just to keep a nice organized output, I'm going to cd out of here. I'm going to make directories web, and then I'm going to make directory web 80, because this is the one on port 80. There was another HTTP service on, let me just show you what I mean. There was another HTTP service on port 8765, so I'm going to also make one called web 8765. There we go. I'm going to cd into web 80. 80, there we go. And because this users.back was on this port 80, I'm going to copy this. So from the downloads, users.back, and I'll copy it to here. So we can see that there's this users.back file. What is this file? We can use the file command to verify this users.back, and we can see this is an SQL-like database. So you can use the tool SQL-like browser, and then users.back to actually view this and view the contents of this. And we can see it looks like there's some sort of tables for users, and it gives us the schema here. So there's a username and password, and we can actually browse the data and we can see the content. So we've got some sort of credentials here. This looks like a hash, right? This doesn't look like a plain text password. It could be. I don't know. So what I'm going to do is I'm going to copy this, and I'm going to. Did I actually copy that? I didn't. Let me do that again. Let me just check I copied that. Yeah, I did. Cool. I'm gonna echo admin and then paste this in here. Oh, it looks like I've lost the copy. That's not great. Sorry about this. Copy. Let's just cd into web, cd into recon web 80, and let's echo this into hash. And let's also, we know the username, so let's just make another one, echo admin. There we go, into credentials. So this hash, right? At first glance, I thought that this looks like a MD5 hash. I can use the tool hash identifier to verify this, and this will tell us it's most likely a SHA-1 hash. It could be MySQL5, which, if you look at it, is basically just a SHA-1 hash, two SHA-1 hashes. So let's Control-C out of this. Instead of getting John open, sometimes we can just check if this has been searched before online. So there's a tool called Hash Analyzer or Crack Station, that's the one. Paste the hash in here and we'll see if this has been cracked before. And it is Bulldog19 SHA-1 hash. So we can actually, I'm going to go VI credentials. I'm just going to update the credentials file here. Let's go admin. There we go. credentials. There we go. So we've got the credentials for something yet we don't know. We can look at that other website, but admin and Bulldog19. There was that other website which I may have forgotten the port on it. So let's go back. I'll do it in here. Recon mmap. There you go. Cat Thorough. It was port 8765. So let's go to this, and I probably will need to copy this IP address. 8765. And we've got an admin panel with a login page, right? So I first thought, look, we've got some credentials. I wonder if they're the credentials from here. So admin Bulldog19, and we log in. Those credentials do work, so that's great. We're in this admin panel page, and it looks like we've got this add a comment to the website feature, right? So what is this? Let's look at the source code. First of all, there's a comment here saying, Barry, you can now SSH using your key. SSH in using your key, which is a bit strange. You definitely don't want to put that comment on a website. And there's also commented in JavaScript document.cookie example equals auth /auth / don't forget .back. So this was a bit strange, right? I didn't know what this is. So let's actually let's just copy this. And this sort of looks like it's some sort of directory, so perhaps this is a file hosted. I don't know. We can find out. And it is. It looks like, you can see there's 996 bytes. This is a file. Don't forget .back. So let's go download this and actually inspect the contents of this again. We can cd to 87 because that's the port, and we can move downloads.don't forget .back into the current directory. We can say file again because we don't know what this is yet, and it says it's an XML document. Okay, so let's open this in Subble. Don't forget .bat, and it looks like cancel. I don't want that one there for a reason. Close without saving. Let's open this one here. Sorry. Replace. Okay, I may have accidentally moved that. Let me just see if I can. Don't forget. I accidentally delete the contents of that one. Let's get this again. Did that download it? I'm not sure. I'm not confident. Auth don't forget .bat. There we go. Move. Okay, let's just strings this, right? As you know, it'll be easier if I do it in here. So this is what it looks like. And if you look at the rest of the JavaScript code, actually, what I'm going to do first, just to show, if we add a comment, let's actually test this feature out. So let's go test. And there's this comment preview, name, author, comment, which is strange. Nothing's outputted. I put test here. If we go back and look at this, right, there's this comment, name, author, and then com. So perhaps if we copy this and put this in here, what does this do? And then it does do a comment preview. It says the name, the author. So we can input XML into this document and it will output it to us. You may have not seen this vulnerability before, but as soon as I saw this, I thought of XML, external entity injection. So let's look this up. XML, external entity injection. So it's also known as XXE or XEE. So it's a web security vulnerability that allows an attacker to interfere with the application's processing of the XML data. So basically, there are vulnerabilities which allow us to execute sort of remote code, server-side code in the XML. So we can inject XML which will perhaps read a file. So there's a POC you'll probably see. Let's try find. This is like a classic POC here. and we create this XML entity, and I'll put it up here, and we're setting it the variable name to be XXE. So we're creating an XML entity. It's called XXE, and what this actually is it's using the system to read the file etc password. So we can put this in the name here, and you specify an XML variable by going XXE and then doing a colon there, a semicolon there. So let's copy this and let's see what this does. Basically, we're trying to read, in this case, the file etc password. We may need to play around with this. It may not work first time, but we see it does. We do get the expected output of etc password. We can see there are two users, Barry, down here, because we know they're users, but they've got the home directory. I don't know what the syslog does. Home, and there's Barry and Joe, right? Two users. You'll recall, sorry, resend. You'll recall, if we look at the source code, Barry, you can now SSH in using your key. So if you are familiar with SSH keys in Linux and where they're stored, you'll probably know they're stored in the user's home directory in a hidden directory called SSH. So in this case, it will be home, and we know there's this Barry user, and when I mean hidden directory, there's a dot before the directory name, so it'll be .ssh. This won't be displayed because it's hidden. The same, if you prepend it with a dot, the same thing happens in Windows. And it says we can log in with a key. SSH keys, they come in a public and private key. The private key is typically called ID_RSA. So I took the guess that, as we've been told, Barry can log in with his private key, his SSH private key, and this is the regular format. Can we read this? Can we inject this into the website and read it? And it looks like we can. Begin RSA private key, and it looks like we've got the private key here. We can see it is encrypted, so we're going to need to do some decryption of that, but we can copy this. We can copy this key, begin RSA private key, like so. We'll copy this here, and I'll move to the exploits directory now. Exploits, just because we're sort of getting our way to initial access, our initial foothold into the computer, and we can paste in the private key here, and I'm going to output this to ID_RSA. So we can just cat this again, and we can see, look, this is the private key, but it is encrypted. So if we did try to use it, it would ask for a passphrase. So we've got some sort of, it's not like two-factor authentication, but they're using an extra factor of protection by encrypting the SSH key, which needs to be decrypted before actually authenticating it. So we can do that. We can use a tool called SSH2John, and this will basically convert the ID, the SSH encrypted key, into a hash, and we can crack that hash with a word list. So I will do that, and so we've got the hashed SSH key. I'm going to use John to crack this. I'm going to use a word list for this, and the word list I'm going to use is going to be the ROCU, user share word list ROCU, and all we need to do is specify the hashed SSH key. I do want to note this may not give me the output like it would if my first time doing it, as I've hashed this, I've cracked this in the past, but we can see, look, pardon me, sorry about that. It says using default input loaded, no password hash is left to crack, and that is because I have actually cracked this in the past. It's not going to waste the resources and do it again. So we can use the command show to show us this key, and I'm just going to pipe this, redirect this to SSH key, and let's just clear and cat out SSH key, and we can see the key is Uriel James. So we can try use this key, but there is going to be one thing we'll have to do before, and I'll demonstrate why we can't use it. At the moment, if you look at the permissions on the ID_RSA key, all other users and all groups have access to read this file. That isn't very secure, and SSH, the SSH client, doesn't like this. So if we tried to go SSH tech IDRSA Barry, and the IP is, just copy it from there, it's easy. There we go. The IP is here. We'll do this. Say yes. It says permissions are too open, so it doesn't like that. It doesn't want it to be accessible by others, so we do have to change this. So if I do chmod 600 and now look at it again, now only me, the Kali user, can read and write this. No other users have access to this, so we should be able to use it. And it does ask for the passphrase, so we'll go Uriel James, and I typed it wrong. And that time I didn't type it wrong and it worked. So we're in as this Barry user. We can ls and we've got the user user.txt. We'll just tack this. We can see it's actually owned by Barry, and Barry has read access. So I don't need to do any privilege escalation to get this. I can cat this out. So we want to get root right. What would you usually do? I typically, when I get initial access on a Linux box, always run sudo tackl. I want to see, do I have any sudo capabilities, and we see we're prompted for a password. We can try a few of the passwords we know, like Uriel James. Didn't work, and we also found Bulldog19. Didn't work. Okay, so that isn't going to work. I don't want to put a word list against that. That's too much hassle. There are much more neat and creative ways to get root. If you recall when we catted out Etsy password, and I'll do it again just to show you, there was another user, Joe. So let's have a look at Joe. cd into Joe, do we have permissions? We do. We can ls, and there's this live.log. Let's just tag this. We can see it's owned by root, and it's in Joe's folder, okay. And it looks like it's got the S bit, it's a suid binary. So when we run this, we'll be running it with the permissions of root. So this is an interesting file. What is this file? Let's use the file command to verify this. And we can see it's an ELF 64-bit. So this is an ELF binary. We can see, yeah, it's a setuid binary. So it will run as root. Let's just run this because I don't know what this live log thing is. And we can see it sort of gives us a log of the requests which are sent against this web server. And it does specify the port somewhere, and it's this one which was 8765. So let's just move this across, right? Let's see if we go to this 8765, if we like make a request on this end, and we can see it updates there. So it does give a live log, which is very interesting, right? So it's basically a log of the HTTP requests which are sent. So let's actually have a look at this a bit deeper. Let's try figure out how this is actually working, or is this like a well-known binary? Is this like a known exploitable binary? One way I typically do this, which is quite neat, it usually does work, is using MD5 sum live log. If we just search up this hash, there is a good chance. And I like using virus total, or just Google virus total. No, come on, virus total. There we go. There's a good chance, if it is a known binary, if it is a real thing, it would have been searched before. So we can just verify it, and it has got no matches. So there is a good chance that this binary, this executable, was made just for this challenge. We can also search this here. Yeah, no founds. So this isn't like a known executable, this isn't a known binary, this is made for this challenge, so there is something, we can't go Googling for exploits basically. We know it's a binary, there may be some strings left over. Let's do the strings command on this just to see if strings is on this. I think it will be strings on live log, and it does work. So we can see some of the modules of the glibc, which are setgid, the setuid, printf. So we can see a lot of the modules which have been imported. If we scroll up a bit further, we can probably see some of the strings. and we can see it's using the tail command tacf on var log nginx access.log. So it's basically reading from this log continuously, I'm guessing, and then it's executing it. And the access.log, if you remember, this was the nginx server. From my nmap scan, we see this at nginx. It's taking the HTTP request logs and displaying it to the system. It's using the tail command, but it doesn't look to be. It's not using the full path for that. So that may stand out as exploitable, because we could create our own tail command and hopefully execute that first. So I'll explain what I mean. Right, when you use a command like tail in Linux, or sorry, tail. Let's just tell. Does this work? Yeah. So it searches in a load of locations to find this file tail, and the order it searches that locations are defined by the user's environment variable path. So we can actually go env, and we can see the path here. So it first of all checks user local sbin. Does tail exist in this directory? No. Okay. Then it will check user local bin. Does tail exist in this location? No. Then it will check user sbin. Does tail exist in this location? No. Does it exist in user bin? And if you actually do which tail, it will tell you the location. And it says it's in user bin tail. So it gets to this, and then it says yes, tail is in this location. It executes it. What we're going to do to exploit this is put a malicious tail, a rogue tail, somewhere further up this chain. And we're not actually going to use this chain. I'm going to add something to the beginning of it, which is a location which I can write to, and it's actually going to be the temp directory. So let's just go cd / cd temp, clear this out. And what I'm going to do is, I know this is going to be executed when this setuid binaries run, and it's going to use the tail command, and I want it to the temp directory to be on this chain. So I'm going to export path equals temp, and then I'm going to basically use colon to separate, and then I'm going to use the path variable, which is just this. So I'm basically I'm setting a new path variable. So when I go env again, we've got the temp directory here. So we now know when we use this, it will first check the temp directory, then it will check the user local sbin directory. But if we have it, if we create a tail binary here, it will use this one first because it's further up that chain. One thing to note, this is a SUID binary. We found out by doing looking at the permissions. It's got the S bit set. I'll show you what I mean. Home Joe live log. It's got the S bit set, which means set user ID. It's going to run with the permissions of root. I can execute it with the permissions of root. And when it runs, it's going to run that tail command, and it's going to find that tail command in the temp directory instead of the legitimate one. Now we know that, I can create a malicious tail, and what I want it to do is just pop a shell, right? I just want to use bash to open a shell, and I'm going to pipe this to tail, right? I'm going to make this executable, so chmod shell, and now if we look at this, tail is here, it's executable. So when it runs, it will execute. When I run this live log tail, my rogue tail will execute, and that will just pop a shell. As it's running as root, because it's a set UID, I will then get a shell as root. So we can verify this works with home Joe live log, and we can see we're now root. Who am I? Root. ID root. So we can cd into root, and there's the root.txt. ls-tech-la. We can get the flag like that. So I'm sorry if I explained it in a bit too much detail here and waffled on a little bit, but we've solved the challenge. We've got the root and the user flag. So yeah, I'll see you on the next one.